Hi everyone, today we will implement moving platforms in Unity 2D. We will create a simple but flexible system where we can design a circuit and make the platform follow it. This is a peek on the final result. I have a platform sprite here. If you don't currently have a platform sprite, you can use any of the default Unity sprites, such as the square one. Let's start by creating an empty game object to hold the sprite in the points. Rename the empty game object moving platform. Reset its transform component and make the sprite a child of it. And also don't forget to add a collider to your sprite. We won't need a collider to implement this system, but if you were developing a 2D platformer game, obviously you want your character to be able to collide with these platforms. Now create a new child of the moving platform, and rename it points to hold all the points that make up a circuit. You can create as many points as you want. For this tutorial, I will create 3 points. And finally, create a new script and rename it moving platform, then attach it to the sprite game object. I have already written the code and I will explain it line by line. Additionally, you can find the code in the description. First, we need a list to hold all the points game objects. There is no need to have a reference to the whole game object. Transform is enough, since we only going to need the position information. Next, we have multiple variables to control the overall movement of the platform. First, we have the movement speed to control the speed of the movement. This will be multiplied by the damping function to smooth the overall process. Smoothing speed variable will be used as a parameter to the damping function. Don't worry, we will check the damping function in a second. Next, we have the stopping distance. This variable represents the distance at which the platform would come to a stop. In many cases, we don't need the platform to reach the exact position of the point, as this would make the overall experience much smoother. Stopping time is used to make the platform wait for a specified number of seconds at the destination point. You can leave it as 0 if you don't want the platform to stop at all. We will use the movement direction vector to store the platform's movement direction. We will see how we calculate this direction shortly. Point index integer is simply a reference to the point transform from the list, so we know which point the platform is moving towards. Timestamp is used to mark the time once the platform reaches the destination, in order to wait for X amount of seconds as specified in the stopping time variable. The timestamp once Boolean variable is used to ensure that the timestamp is marked only once. This Boolean will become clearer shortly when we see the functions. In the start method, we call the getMovementDirection function to retrieve the initial movement direction of the platform and store it in the movement direction variable. I will soon explain how we calculate this direction. It's actually quite simple. And then we simply initialize the private variables we have declared previously. The timestamp once is set to true initially because we need to mark the time as soon as the platform reaches the destination. Now let's see the getMovementDirection function. As you can see, it's pretty simple. We subtract the platform position from the past point position to get a direction vector. The point position parameter represents the target point we need to move towards. In the update method, we utilize the translate method on the transform property to move the platform in the direction we calculated. The translate method moves the transform in the direction and distance of the translation parameter passed to it, so we normalize the movement direction to a length of 1, then multiply it by our movement speed variable. Finally, we apply a damping function to smoothen the movement. This damping function called the exponential decay, and we subtract it from 1 to ensure the transition is smooth and consistent over time. Now the platform is moving towards the point the movement direction pointing to, but once the platform reaches the destination, we have no way to reach the next point in the list. So here comes the next movement direction handler function. Let's see what this function does. We start by creating an if statement to check if the platform has reached the destination. This is done by examining whether the magnitude of the calculated movement direction is less than the previously specified stopping distance. If you are familiar with vector math, this will be straightforward. If you're not, don't worry. Let's consider this example. Let's assume that the green rectangle represents our platform, the red circle represents the destination point, and the arrow represents the calculated movement direction. The platform is located at the origin, and the destination point is located at -4 on the x-axis and 9 on the y-axis. The stopping distance is set to 1. Since we know the starting and ending points of the movement direction vector, we can calculate its magnitude using the Pythagoras theorem, which is 9.85. Now let's move the platform in the movement direction just like we did in the code, and see what happens. The platform has come to a stop at the exact position specified by the destination and the stopping distance. Let's see why this worked. From the new coordinates of the platform, we can calculate the new magnitude of the movement direction vector. If you perform the calculation as I explained previously, the result would be approximately 0.4, which is less than 1, and that's why it stopped. I hope I have explained everything clearly. Back in the code, after we have completed our check to ensure that the platform has reached the destination, we need to set the movement direction to 0 temporarily until the stopping time period ends. Here we simply ask if we haven't marked the current time yet, which is the time the platform reaches the destination. Let's mark it and exit this if statement immediately because remember, this function happens every frame. If the stopping time period ends, we move to the next point in the list. If the next point is the last, we simply go back to the first point in the list. Finally, the movement direction is recalculated by passing the new point to the getMovementDirection function, and all the time variables are reset. To visualize the points we implement the onDrawGizmos method, we simply loop through all the points in the list, and draw a sphere at the center of each point. In the editor, select the platform sprite, and drag all the points to the list variable in the moving platform script. In the scene view, position the points game objects as you like. Adjust the settings variables to control the movement, and choose the values according to the pace of your game, whether fast-paced or slow-paced. It's too fast. Let's change the value to slow it down a bit. Great, that looks good. Thank you for watching, and see you in the next video.